critical points of a function are where the derivative of the function equals 0 or where the derivative fails to exist. So particular values for x that might cause a divide by 0 error or something like that for the derivative. So for this function, whoa, there we go, that's better. We evaluate the derivative. This is x squared plus 7x plus 6. And we want to set it equal to 0 because critical points are where the derivative equals 0. And so this is a nice little quadratic. So there's two values for x. Critical points are -1 and -6. So if I type that in, they want commas. So -1, comma, -6. So critical points for this function, we first want to evaluate the derivative. And so in case you're not sure about this notation, that's -6 times sine of x squared. So we have to use the chain rule here. The derivative of the outermost function, it's a power function. The 2 comes down, multiplies, then gets reduced by 1. But then we need to multiply by the derivative of the innermost function. So the derivative of sine is cosine. So that's our derivative. We need to set the derivative equal to 0 to find critical points. And in order for this to be 0, it says on the interval 0 to 2 pi. So if x is 0, then sine of 0 makes 0. And then we got a true equation. So that would be a value for x that makes the derivative equal 0. At pi over 2, cosine pi over 2 would be 0. So 0 times all this stuff makes 0. At pi, sine of pi is 0. And at 3 pi over 2, 3 pi over 2, cosine is 0. And then 2 pi, if you plug that in, sine of 2 pi is 0. So those are all things that would make it equal 0. So 0, I can remember that. 0, comma, no, they won't let me type in pi. Pi over 2, pi, 3 pi, oops, comma, 3 pi over 2, comma, 2 pi. Okay, I think I get everything.